All right. Okay, what I want to do this morning, girls, is I'll take any questions from 6 the start of this, then I want to go through chapter 7:1 with you, and then we'll get into physics again this morning. All right. Any questions from chapter 6 that you want to look at so we can finish that chapter off?
No, I don't have any questions from chapter 6. I'm just wondering if you got my assignment.
You texted to me, did you not?
Yeah.
Yeah, that's not, I did get it, but I don't know what I'm going to do with it.
Did you get my assignment?
No, I did not, Brendan.
No?
No.
Okay. I'll have to resend it.
Okay.
I thought I put it on an email to PDF.
No, I didn't get it anyways. Yeah, if you could send that to me. Yeah, if you could send that to me, I'll have those things marked. I've actually got them all marked except for yours that I'm going to mark. And then I will, I'll put the answers on Edmodo tomorrow, or we'll go through them tomorrow, one or the other. Dylan, there's no way you can email those to me, is there?
Let me try right now.
Well, you don't have to do it right away. I don't know how I can do it. I could probably, I tried sending them to OneDrive yesterday. I don't know how that worked. Oh, it's there. Hold on a second. Maybe I got it. Oh, let me just have a look. Where is? Oops. I'm sure it would. OneDrive.
So when we send them an email, like, okay, see if that works.
Anyways.
Because I emailed it to your PDF and I emailed it to your pictures.
Okay. Okay. All right. So everybody's okay with chapter 6 then? Okay, Dalen, I got yours. All right. Okay, so we're still gonna work, Dalen. Like it's fine. I'll print it this way, but let's still try and print the individual pages, and sometimes the sizing doesn't work. Let me make sure the sizing, because that was the problem I had with it.
Getting it, like I'm gonna scan it on my phone.
Yeah. This one worked, Dalen. Like the sizing was better for this one. The last time you sent it, I could only get a corner of it. Yeah, so I printed it off just now. So we're okay.
All right. Mr. Newton, I do all my email through the laptop, and my sister's writing an exam on it right now, so
Okay.
I think she's done that around, so it's okay if I send it to you too.
Yeah, that's fine. Sure. Okay, so I'll go through that assignment with you tomorrow. Let's look at 7:1 today. 7:1 is something we've done and applied already. So we should be so if you recall from applied math.
Hey, can you turn off the mic so I can see the board, please?
Say that again.
I just need Dalen to shut off her mic so I can see the board because it keeps on switching to her screen.
Okay. Okay, so what we'll remember from applied is there's 4 characteristics that we need to know about this. So, okay, so characteristic number 1 is the y-intercept is 1. Okay, the end behavior for this was 2 to 1. All right, now that's provided that B is a positive value and A is a positive value. But just for a standard one, let me refer to y equals 2 to the x. Okay. The third thing is there was an asymptote. Excuse me. The asymptote is at y equals 0. And what was the fourth thing? Can't recall the fourth thing right now. Let me see if it's in here. I don't see anything in here. Oh, sorry. X is an element of all real numbers, right? But the range, sorry, I gotta write the range over here. It's not very neat. The range is y is greater than 0. So the domain is equal to 0 is greater than 0, not equal to, greater than 0. So these were the 4 characteristics that we needed to remember for an exponential graph. So let's look at the example on page 230. It says graph each exponential function and identify the following. So first one was y equals 3 to the x. So there's y equals 3 to the x, the domain for this graph. The range for this graph, 0 to infinity, not including either one, not inclusive. The x-intercept, there is none, so no x-intercept. Y-intercept is 1. Whether the graph represents an increasing or decreasing function, it's increasing from quadrant 2 to quadrant 1. And the equation of the horizontal asymptote. So the asymptote's equation in this case is y is equal to 0. Doesn't change. Okay, so that's for y equals 3x. So that's when my b value is greater than 1. That's for any b value that's greater than 1. For a b value in which the value is between 0 and 1, for example, that example b, that is a graph of y equals 1/3 x. So there's the graph of y equals 1/3 x. So the only thing that changes out of all of this is that it is now a decreasing function from 2 to 1. So if I'm following through in my workbook, in 1b there, it says the domain of the function is, so you put x is an element of all reals. The range, y is greater than 0. Graph has no x-intercept because the graph never intersects the x-axis. The y-intercept of the graph is 1 because 1/3 to the 0 is equal to 1. The function values get smaller as x values get larger, so the graph is decreasing. There is a horizontal asymptote at y equals 0. So all of the information, if I compare y equals 3 to the x to y equals 1/3 to the x, all of that information stays the same. The only change that we have in that information, is that this is an increasing function. It's going up. That's a decreasing function. Okay, and again, we studied this in applied. We looked at all of these possibilities. Look at example 2, page 231. We're given the graph. It says, what exponential function can be used to describe this graph? All right. So it's in the form y equals b to the x. The value for b has to be greater than 1 because it's an increasing function. So how do I find out what b is? Well, when I look at when x is equal to 1, that should be whatever b is. That value for y should be what b is. So if I look at that graph, it looks like it's going through when x is 1, y is 2. So the given graph includes the ordered pair 1 and 2. So when x is 1, y is 2, that means that this equation has to be y equals 2 to the x. So you can conclude that c is equal to 2. Therefore, the exponential function that can be used to describe the graph is y equals 2 to the x. Choose a point other than 0 and 1 to substitute into the function to verify the function is correct. So they put 4 in and get 16. So you compare it, 4 and 16. So the left side equals the right side, so we've got it right. Okay, so I went through that quickly, but there's not a lot to it. Let's look at the problem on page 232. Fong has just graduated from university and wants to begin her retirement planning. Her investment advisor suggests an investment that he expects to double in value every decade. The estimated growth rate is modeled by the exponential graph as shown. So it says state the domain and range of the function and explain the significance of the y-intercept. Okay, so looking at that graph then, the domain of that function is x is greater than or equal to 0. The range of that function is y is greater than or equal to 1 by the looks of it. Okay. What's the significance of the y-intercept? Well, if you look at the margin, it says the value in dollars. So she's invested $1 to start with. It says write an exponential equation that expresses the value of each dollar invested after t decades. Okay, so I'm gonna follow through using your fill in the blanks. Since time is graphed on the t-axis, the domain is x is greater than or equal to 0. The range of the function is y is greater than or equal to 1. The y-intercept is 0 and 1, represents the initial value of each dollar. Since the point 1 and 2 is on the graph, the equation is y equals 2 to the t. So this is your B part. So 10 years is 1 decade. The point 1 and 2 is on the graph. So in 10 years, the value of $1 is 2 to the power of 1, or $2. So after 10 years, whatever she invests is going to double. The point, something in 8. So 3 and 8 is on the graph. So the coordinate 3 and 8 is on the graph. So it will take 3 decades or 30 years for each dollar of the investment to be worth $8. So to get 8 times the amount you invest, it's going to take 30 years. Create a table of values for V of t, which is equal to 2t. So you got 2 to the 1 is 2, 2 is 4, 3 is 8, 4 is 16, and 5 is 32. So it says the table shows that the number of decades is between 1 and 32. Sorry, 1 and 5. You can determine the best estimate for t by looking at the values between these numbers. Use systematic trial to find the value for t when v is equal to 26 or approximately 26. I'm going to leave that out. Okay, so basically from this morning, you need to know your 4 characteristic properties, whatever you want to call them, of y equals a b to the x, and that's it. So again, this is not new to you. This is something we did in applied. All right. So I'll get those assignments back to you tomorrow. I will do the assignments. I'll look at it on the board tomorrow as well. Just any of the questions that we want to go through, and then we may look at 7.2 tomorrow if we have time. But I'm not in too much of a hurry on that just yet. Okay, so that's what I have for today for pre-calculus. Any questions about or any concerns about pre-calc? No? Okay, let's get physics out then right now, please. Well, let's have a look at 40S physics. So I wanted you done to the end of 18 this morning, or by the end of today. Done by the end of, so page 457, 458, you need to be done to the end of the 18th question on that. Any of those questions you would like to see done this morning?
Question 4 is like a carry on of question 3, but how do you find the wattage rating?
Good question.
Question 4.
No, I said good question. I said find the power. The amount of find the amount of power in it from that. So we can. So you're given the voltage and you're given the amperage, right?
Yeah.
Okay. So just let me clear my board off here, and then I'll. Okay, so the information I'm given is 117 volts. Current is 0.52 amps. Time is given in 12 minutes, so that's 720 seconds. Okay, and you want to find the power. So you can use any one of the power equations.
All right.
Let me just have a look here, which one. So you're given V and I. Well, so that's the one you want to use. So the original power one where it's V and I. Okay, and then 117 times 0.52.
Okay.
Okay. Other questions from 1 to 18 there?
Yeah.
Okay.
Okay, can we do 11?
Sure. Okay. Electric energy costs 9.2 cents kilowatt hour. What is the cost of heating 4.6 kilograms of water? So I've got 4.6, I'm going to change that to grams, so 4,600 grams of water. From 25 degrees Celsius to the boiling point, so that's 75 degrees Celsius, right? I know my C is 1 calorie per gram degree Celsius. If I need that, maybe. Okay, so if electricity energy costs 92 or 9.2 cents kilowatt hour. So what is the cost of heating 4.6 kilograms of water 25 degrees Celsius to the boiling point? All right, so what do I need out of this? I need to get my power out of this. So okay, so I need power, which is work over time. Shoot, I don't remember how to do this. Energy is equal to power times time. So
Maybe you could solve for Q.
yeah, that's that's what I was looking at. But then, how does Q help us get to our power then?
Work. Well, power is
We
oh, I guess that's different.
we do know that this, because it's kilowatt, it wants to find it for 1 kilowatt hour. So just a second here. Q equals MC delta T. I feel like this is going to be a lot, the way I'm going to do it is going to be a lot more work than I want. Just give me a second.
Do you want me to tell you what they have in my book?
Oh, I got the answer, but I want to see how to get it. That's what I need. So just a second
Yeah,
here.
I just.
Yeah. 1 second. I just need to get a little bit more organized here. I'm going to have a look at it in this book here. 457.
Do you think you could send us like the full answer key?
Yeah, well, somehow. I'll have to figure out how. Maybe I can scan it. Okay, this is a confusing way to do it, but all right. Cost kilowatts per kilowatt hours times the cost per kilowatt hour is equal to MC delta T. So that's Q times J these. Okay, so this is what they have. They have MC delta T times J. So, sorry, I'm going to go back. I'm going to just play with this for 1 second here. Oops. I got to go back. Okay, so we can go back all the way to Q is work over J. So, okay, that's how it comes out like this. All right, I'm going to explain it. So, work is equal to Q times J. So work is the electric energy. All right, so that's what we need to multiply by the 9.2. Okay, so this is how we end up getting what we get. It is we use MC delta T here times J. All right, and then we're going to multiply that by 0.092 because that is per kilowatt hour. Okay, so now I'm going to convert. I'm going to convert my mass. I'm going to leave it as 4.6 kilograms. 4.6 kilograms times 1 kilogram or kilocalorie. Really doesn't matter, but I'm putting it in anyway. So kilocalorie per kilogram degrees Celsius times 75 and then times 0.092. So we're going to take 4. That's the change in temperature from 25 degrees to 100 degrees.
Oh, because 100 is the boiling point.
That's right.
Okay.
Actually, I've got this wrong too. Sorry. Or no, I don't. That should be right. 0.092, is that 9.2 cents? Or is it given as 0.92 cents?
9.2 cents, so that's 0.092.
Right. Okay. So 4.6 times 75 times 0.092. I'm off on the decimal place here, I feel like. Oh, I didn't times it by J. I forgot my J. So my J is let me do this again. I got this buggered up here. So my cost is equal to, so that is, let me just write that out. I got 4.6. Well, I got it. Okay, so 4.6. That's my M. My C is 1. My T is 75. My J is 4.19 divided by 1,000. So 0.00419.
Why are you dividing it by 1,000, sorry?
Because that Joule's constant is given 4.19 calories per what is it? Joules per calorie.
Joules per calorie.
Right? And I need to change it to kilocalories. So I have to change it to joules per kilocalorie. So I have to divide by 1,000.
Okay.
Okay? And then that's times 0.092 there. All right. Now let's see if we get our cost out from that. do that? I'm missing. I'm getting 13 cents instead of 3.7 cents. Oh,
Yeah.
yeah.
13 cents too.
We have to divide that by, oh, shoot. Okay, let's try this again here. So I got 4.6 times 75 times 4.19. We are working these out in seconds instead of hours, so we got to divide by 3,600. Yeah.
Aren't you solving for the work, not the cost then?
Yeah, I am, but okay, so work, all right, so we also have to factor this into it, that. Right? We have to, work is what is it, Q over T. That's what work is. So I also have to factor in my time, and my time is for 1 hour, which we have, if we work this through, is in seconds. So I've got to, okay, I'm going to write out exactly what we have in the book here, and I'm going to go back, and we'll explain it that way. This is a mess right now. The way I've done this is a disaster. So I'll get this, so it has kilowatt hour. So that's given to us. Times the cost per kilowatt hour.
I can't see anything.
You need it bigger?
I can't see anything either.
Oh, sorry. My thing just shut. My bad. That was my iPad needs charged. Okay, so the cost is, I'm gonna write down exactly what they have here. So kilowatt hour times the cost per kilowatt hour. Okay, and that's equal to MC delta T times J times the cost per kilowatt hour. So my cost then is equal to, I've got 4.6, and they convert that to, or sorry, 4.6 kilograms times 1 kilocalorie, so that's my C value, times my T value, which is 75, times 4.19, and I need to convert that to, from joules calories, so actually I should have had this. This should have been 4.19 times 10 to the third. There's the mistake I made on that last board. So that's going to change that to joules per kilocalorie. This is why I don't like working in I prefer not to work in kilos, because we have to do a lot of conversions that way, but that's the way it goes. So now I have to times that by, so here's the thing we didn't add in here. A kilowatt hour, we have to change, because we're actually calculating it in watts per second. So that's 3,600 watts per second. So this is,
I got the right answer when I did that.
okay, and then by 0.092. All right, so 4.6 times 75 times 4,190 divided by 3,600 times 0.092. And I get, what did I do wrong here? I still got it wrong. 4.6
I got mine right.
Yeah, okay, I did too. Oh,
I did.
here's, you gotta, it's right here. This is 3.6 times 10 to the 6 watts per second. Okay, there's 3,600 seconds in an hour, and there's 1,000 watts in 1 kilowatt. So had I done that, and then if I divide that by 1,000, I get the right answer. So there's a lot of work to get to that right answer.
Okay, wait a second.
I'm not going anywhere.
Okay, so that 3.6, do you times it by that? 3.6 times 10 to the 6?
So you would, yes.
Divide it.
Yeah, no, so what you're doing is you're dividing by 3.6 exponent 6.
So you're dividing everything by that?
Yes.
Okay.
So I would go 4.6 times 75 times 4.19 exponent 3 divided by 3.6 exponent 6 times 0.092. This is basically the major, there's two major things that we had to look at in this question. This was one of them. Changing kilowatt hours from watts per watt seconds. That's our major right there.
Okay, now I get it, but I'm a decimal place off, like that, or I get 0.0369.
Yeah, that's right. That's right.
Oh, I get it. I get it.
That's zero.
That's a dollar value, right?
Yeah.
Sorry, there we go. That's a dollar value. And if I change it to cents, it's 3.7 cents. Okay. All right, any of those other questions?
Number 15.
15?
Yes, please.
You're given the power of 4 watts. You're asked to find the maximum voltage across 2 ohms. So what power equation has V and R in it?
It's P equals S squared.
Yeah, but which one deals with V and R? So you have 3.
Oh, sorry, I thought you said P.
P is equal to V squared divided by R.
So you'd have the square root of P times R. Okay?
Yeah.
All right, any others? So I have a 3-question assignment for you that I'll put out tomorrow. And I would like you to start tomorrow as well working on those, on the worksheets. Okay? And I may have an assignment for pre-calc as well. I haven't decided that yet, but I'll think about that tonight. All right?
Pre-calc, what would that be like for?
Just like 5 questions off of chapter 6.
Oh, chapter 7 that's it.
Yeah, no, nothing on 7. 7 I'll assess next week.
Okay, do you think you could send me essay application for physics?
I'll do what I can, Dalen.
Okay, thank you.
All right. If I scan it, I could probably put it to a PDF and then put it onto Edmodo. Would be the way I can do that.
Okay, thanks.
All right. Anything else this morning, gang?
I'm good.
Okay. Okay.
Have a good day.
Yeah. Enjoy the rest of your day. We'll talk tomorrow morning. Okay, bye.
Bye.